Okay, previously we derived this, it's not really a formula, but we had this derivation for an expression that gives us a particular solution to the initial value problem. Y prime equals P of Ty plus G. And let's put down a good copy of this. So to the non-homogeneous system, y prime equals P of Ty plus G of T with initial condition y of T naught equals y naught. We're going to apply the process that we used to derive this in order to find a solution to the system y prime equals this matrix, here's our P of T matrix, times y plus the non-homogeneous matrix or vector T e to the T with initial condition y of 0 equals 1, 1. Now, first thing we do is we solve the homogeneous problem. And I'm not going to go through the details of solving that. We get our characteristic matrix 3 minus lambda 3, 2, 4 minus lambda. We get characteristic equation, which I believe is lambda squared minus 8 lambda plus 15, giving us solutions lambda equals 1 and lambda equals 6. Plugging each of these back here and finding our eigenvectors, we find that the eigenvectors are, we get eigenvectors multiples of negative 3, 2, giving us for lambda equals 1 this solution, and a multiple of 1, 1. So for this value of lambda, we get this solution, and here's our psi matrix. Now, just alluding to the steps that we would take, we assume solution psi of t, u of t for the non-homogeneous equation. And after taking derivatives and so forth, we find that u of t is going to equal psi inverse times our g of t function. In this case, that's going to be the inverse of our psi matrix multiplied by the t e to the t, the non-homogeneous part, this being the g function for this particular matrix equation. Remember that the general equation is y prime equals P of Ty plus G of T. So here's our G of T, here's our initial condition, y of 0 equals y naught. Y naught is the 1, 1 vector in this case. Now it's very easy to invert a 2 by 2 matrix. So what we need is we need to get psi inverse. And I got this as u of t, this should be u prime of t. And that reminds me I had a omission up here. This should have been psi of t naught times u naught. So we get an equation for u prime of t. All we have to do is invert this matrix and multiply it by this vector. And having done so, that's going to give us the u of t vector, and we're going to just multiply that by the psi matrix. So that takes a little bit of manipulation, and we got to be careful about our constants and so forth. Write things down carefully, but this is not particularly difficult. Of course, it's always a challenge to remember the steps and remember why you're taking them. Okay, the inverse of the psi matrix is just the inverse of this matrix, and there's quick and dirty ways to take the inverse of a 2 by 2 matrix. I didn't really leave myself room to write my constant out here. I'll write it on the right and then we'll fix that. We get e to the 6t, negative 3e to the t, and negative e to the 6t negative 2e to the t multiplied by the determinant of the matrix, which is then going to be multiplied by 1 over. Okay, the determinant, we're going to get e to the 7t either way. We get negative 3 here, and we get another negative 2 here. And just calculating the determinant, we get 1 over negative 5 e to the 7t. And now we're in a position to calculate our u prime and see if we can't integrate it. U prime just going to be this inverse matrix multiplied by this column vector. Simply writing out u prime of t equals psi inverse times t e to the t. We just write the t e to the t vector, the inverse of the psi matrix, and we do the matrix multiplication. And we get negative 1 over 5 e to the 7t. Now e to the 6t times t is t e to the 6t. And e to the 6t times e to the t is e to the 7t, and that's negative, so we get negative e to the 7t. Negative 2 e to the t times t is negative 2 t e to the t, and negative 3 e to the t multiplied by e to the 3t is negative 3 e to the 2t. Then we can divide through here. We're going to be changing the sign of all these, so this will be negative and the other three terms will be positive, and our power of t is going to decrease by 7, so we're going to get negative 1/5. Going to have a 1/5 coefficient for each of these. That coefficients will be 2/5, 3/5. But okay, we get negative 1/5 times e to the negative t, trying to be careful here, minus, except that's now going to be plus 1/5, and that's just plain 1/5. Now let's hold up for a second and see why this occurred, why we just got a constant term here. Notice that one of our eigenvalues is 1, so we have e to the t as a coefficient of our eigenvector. And here we have an e to the t in our non-homogeneous part. So this matches up with this eigenvector and ends up giving us, well, the result of that is this 1/5. I'm not going to trace where all that comes from in the arithmetic here. You can do that if you wish. But this is a symptom of the fact that we do have an e to the t here, and e to the t is one of our, well, 1 is an eigenvalue, so e to the t is an e to the lambda t, multiplied by then an eigenvector to give us this. And let's not digress anymore, let's move forward. Okay, I've gone ahead and filled in the rest of this calculation, no point in belaboring it. And you might notice that I also put the t into this term, which I left off a minute ago. Now this is our u prime of t, and if we look at this, we can be kind of relieved. There's nothing here that we can't integrate fairly easily. I'm not going to go through the details of these integrations. I'm just going to write down the results because, again, these are all integrals that you've done many times in this course. We have to use an integration by parts on this term and this term. This one's just a straightforward integration. So I'm just going to write down the result. And I'll do that off camera.